So today we're starting with the law of sines. Basically, law of sines is SOHCAHTOA for oblique or non-right triangles. Okay, so let's look at some of the necessary information that you need to know before we get started. So we're going to start solving oblique triangles, which are triangles that have no right angles. Okay. The standard notation for triangles, basically we label triangles, their angles with capital letters A, B, and C, so they're capital, those are angles, and their opposite sides are labeled with lowercase letters that correspond to those angles. So for instance, angle A right here is opposite from side A, and angle B here is opposite to side B, and angle C is opposite to side C. So triangles get their names from their angles. So this is triangle, like we wrote it, this is triangle ABC. Okay, capitals. So it doesn't really matter which corner I put these at as long as the letters are opposite from the angles themselves. Okay, so sides and angles have to be opposite each other. All right. To solve an oblique triangle, we need to know the measure of at least one side and two other measures of the triangle. So we have to have one side. And then we can either have two more sides or two angles or one other angle and side. But to solve an oblique triangle, we have to have one side. We can't just have all three angles because you won't know the size of the triangle. You'll know the shape, but not the size. Okay? Now, this breaks down into four cases that we're going to be dealing with. Case 1, two angles and any side. Okay. Now, if you remember from geometry, we dealt with these names with congruency. So the order of these letters matters. So, for instance, angle, angle, side, that means I have an angle, and then a non-included side. So it looks like that. Okay. Versus angle, side, angle, which is angle, side, and then angle. So see how the side is in between the two angles? The side is in between the two angles. Versus this, the side is not in between those two angles. So either those two cases, so when you have two angles and any side. The second case is side, side, angle. So again, if we have a triangle like this, order matters. So side, side, and then an angle, which means the angle cannot be in between, cannot be here at this side, or this angle here. Okay, it's side, side, and then angle. So that's case 2. Then case 3 is side, 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 and I don't think I really need to draw that triangle. It's basically when you have all three sides. And then our last case is, of course, side, angle, side. So that's a triangle right here. And then you have side, angle, and then side. So this is the case where you have two sides and the included angle. Versus this one, you have two sides and not the included angle. And this is important because depending on which case, depends on which law we're going to use. So for the first two cases, we can solve them using law of sines. The second two cases, we have to use law of cosines to start it off. Okay, so right now we're just going to be learning law of sines. We'll do law of cosines later. So, law of sines. If we have a triangle ABC and sides ABC, then we can use this ratio, this proportion, okay, of the side length divided by the sine of the angle. And law of sine says that for a triangle to exist, an oblique triangle, or technically any triangle, that these three ratios have to be equivalent. Okay? So this one here, this has to be equal to this and has to be equal to this. Okay? It's kind of like SOHCAHTOA, it's kind of like Pythagorean theorem, where if for it to be a right triangle, it has to work in the Pythagorean theorem. Okay. Now, I don't like this version of it. I use the reciprocal version. So it's the law of sines. It's just the reciprocal form, okay, where it's the sine of the angle over the side length. And just it's aesthetics. I don't like having the trig function in the denominator. It's just a personal thing. Plus, when you're talking about a, little b, or little c, they're usually their side lengths. They're just numbers. So it's just I have that trig divided by a number, which is just easier to deal with as far as I'm concerned. So that's just personal preference. But you can use either one. I prefer using the reciprocal form, the one on the bottom. Okay. But basically, this is just a ratio or proportion set up of three different ratios, and they all have to be equal to each other for the law of sines to work. So this is one of our cases, given two angles on one side, AAS. Okay, so we're going to work this real easy problem. So find the triangle for the triangle below. They've given us angle C, angle B, and side B. We're going to find the remaining angles in the sides. So we're going to apply this law of sines. So the first thing that I always tell my kids is set up your information. Okay, so I have this triangle, I have these angle measures and the side length. And I have my triangle here drawn out, but I'm going to create a table. And my table is going to look like this. Okay, I have angle A, angle B, angle C right here. Okay, and then I have side A, side B, and side C here. Okay, I would set it up this way every single time, and I'll explain why in just a minute. But notice I'm going to write the numbers in, like 29 degrees and 102 degrees, and side B is 28. And then I've put these lines right here. This is the information I need to find. So the givens don't have a underline. So I know those are what I was originally given. So these are my three pieces of original information, and these three that have these lines here, that's what I'm finding. Okay, so it kind of helps me there to kind of set up or organize my thoughts. Okay, now I'm going to use the law of sines. So the law of sines says that I can use these ratios set up in this proportion. Now I'm not going to use all of them at the same time. Okay, I'm going to use two. So when you set up a proportion, it's set up between two ratios. So I can either use this one, or I can use this one and that one, or I can use that one and that one. It doesn't matter, but I'm going to use two of these to set up a proportion, cross multiply, and solve. Okay? So here we go. Now the first thing I notice is that I've got two angles. I have this angle 102 and this angle 29. So I have angle B and C. And everybody remembers from geometry, a triangle has to add up all of its angles to 180 degrees. So to find the third angle, angle A, I'm going to take 180 degrees and subtract B and C, and I find that angle A is 49 degrees. So I'm going to go back and I'm going to put in my angle 49 degrees. So now I know all three angles. Okay. Now, to do law of sines, you need one full ratio. Okay, in order to set up my proportion to do law of sines. We're going to use that initial ratio for both calculations. So that's the other reason why I tell you to set it up this way. Because this value's right here, this is my given ratio. And I'm going to use that ratio for both calculations to find side A and side C so that I'm consistent. Okay, and then I'll tell you another reason in just a minute. So I'm going to use this ratio. So notice I'm going to look for this. This is what I'm looking for. I know this, and I know that. So again, I'm setting up a proportion to find side A. And if I want to, I can rewrite my equation, and I get A equals B times sine A divided by sine B. And that's what you get when you cross multiply. So if I take this times that, and then divide it by that. Okay, not any different than if it were like this. 1 over 2 equals, let's say, 4 over x. If I was solving for x, I'd do 2 times 4 divided by 1, and that would give me my x. It's the same thing here. Okay, we just have more letters. So now I've got these three pieces. I plug in those values. So 28, that's side B. 49 degrees is angle A. 29 degrees is angle B. And then I plug it into my calculator. Make sure your calculator's in degrees. And I get approximately 43.59 feet. Okay? So that's side A. Now, I'm going to find side C. So I set up my proportion again. But this time, notice, I'm using the same original ratio. So this one that I started with right here. I'm going to use it again to find side C. And now the reason is because we wouldn't want to switch to side A because we have this as an approximate value because we had to round it. But B is an exact value, so we won't have any kind of rounding error. So we do the same thing. Cross multiply. Plug in our values. Plug it into the calculator, and we get 56.49 feet. And that's it. So side A is 43.59 feet, and side C is 56.49 feet. And we're done. We've solved my oblique triangle. We found all the missing pieces of information. Okay? Found all the sides, all the angles. That's it. So basically, law of sines is nothing more than proportions, cross multiplying. Okay? The hardest part is setting it up, and that's why I'm saying make sure you set it up this way. Okay? All right. Let's try another one. Okay? So I've given you this right triangle. Oh, non-right triangle. Okay? So they told me angle A is 43 degrees. So this is 43 degrees. Angle B is 67 degrees. And side C right here is 45 millimeters. Okay, and they want us to solve this triangle. Okay, so we're going to use law of sines. It's one of our cases. This is angle, side, angle. So again, we're going to do the same thing. We're going to set up our equation. So like I said, I'm going to put 43 degrees here. B is 67 degrees. C is 45 millimeters. I need to find this angle, this side, and that side. Okay, and this is what I expect to see when I see your work for these. Okay, I expect to see angle A, angle B, angle C, side A, side B, side C. Okay, now notice I don't have a ratio right here. I'm missing, and that's, like I said, I need angle C. Well, I can find angle C because, again, all three angles should add up to 180 degrees. So we take these two angles, we subtract it from 180, and we find that angle C is 70 degrees. So now this right here is going to be my ratio. So when I go to set up my first equation, okay, basically what we're going to do is we're going to use that for both of them. Okay, so my first ratio, and I'm just going to write it, we're going to be using sine C over C, and I'm going to look for A first. Sine A over A. Plug in what I know, so it's going to be sine of 70 over 45 equals to sine of 43 over side A. Okay, and then we're going to cross multiply and plug it into our calculator. Okay, so basically it's going to be 45 times the sine of 43 divided by the sine of 70, which is approximately 32.66 millimeters. Okay, so again, when you cross multiply, it's going to be this times that divided by that. Okay? So there's side A. So side A is 32.66. And see, I have this ratio of A now, but when I go to find B, I'm going to start with, again, what I started with. Sine C over C. And this time, this is going to be exactly the same except B. Then plug in what I know. So sine of 70 over 45 equals the sine of 67 over B. So we solve for B, and again, it's going to be this times that divided by that. And you get B is 44.08 millimeters. So 44.08. Now, the last thing you're going to do is check to make sure your answers make sense. Okay, so the bigger the angle, the bigger the opposite side. Okay, so 70 degrees, my biggest angle of the three angles, should have my biggest side, which is 45. Yep. 67 degrees is really close to 70. That's why this side B is really close to 45. See how it's 44 and that's 45? And the smallest angle, which is A, does have the smallest side, which is 32. So if you were doing this and you found side B and side B was like 50 something or bigger than my 70 degree, then you did something wrong. So always make sure you check your answers. But that's the law of sines, okay? Just cross multiplying in proportions. Tomorrow we'll talk about the ambiguous case for the law of sines.